this tutorial, we'll see a different technique on integration. So the technique is partial fraction decomposition. So in partial fractions decomposition, we have 5 methods in partial fraction decomposition. So the first part we'll do on linear factors. The second part we'll do on repeated linear factors. And again, the third one we'll do on quadratic factors. The last, not the last, we'll do again on repeated quadratic factors. Okay, so the last part that is on E, we'll do on improper fractions. Okay? So we'll do improper fractions. So once we'll be doing this, so we'll start with the linear factors, repeated linear factors, quadratic factors, repeated quadratic factors, improper fractions. I'll do them, I'll try to explain using examples. So in partial fraction decomposition, just a small explanation of that, we are told, for example, we are given 5 divided by 2. So I'll just try to explain what is this partial fraction decomposition. So in partial fraction decomposition is where we are given something like maybe 5 divided by 12. Okay? So we are trying to decompose this fraction such that we get partial fractions. For example, we get a certain number divided by maybe, I can just say, let's say this is 12, for example, plus b over 12 again. So as you can see, these two parts, they are partial fractions for this whole fraction. So in partial fraction decomposition, it's where we're given a fraction, then we try to decompose it in terms of this way. So this technique, after understanding how partial fraction decompositions are evaluated, we'll now find, using calculus 2 now, we'll now find the integrals of partial fraction decompositions. So from there, we'll try to evaluate that, for example, something like that. So I'll just start with the linear factors. I'll try to explain what are the linear factors using an example. Then from the linear factors, go to the repeated linear factors and so on and so on. So from there, let's just start with the linear factors. Okay? In linear factors, this is where, let me just try to explain this. This is where maybe you are given any variable, any number, let's say 3, divided by a quadratic equation. So for example, x squared plus 4x plus maybe 3. So in linear factors, once given something like this, we are told we'll have to factor out. Let's find the factors for this. For example, we usually say, I'll just say maybe the factor is x plus 4, x minus 4, for example. Though it's not a perfect square, let me just place 3 here. So once we're given a function like this, for example, we'll have to factor the denominator. So the first step is to factor the denominator. We factor the denominator. Once you factor your denominator, you will get this. So our evaluation will be the integral of maybe 3 divided by x plus 4, okay? And again x minus 3. So from there, this is how you will separate your integral to be this. Factor out the denominator, get something like this, then do the partial fraction decomposition. So from this, just the explanation for that. So in linear factors, I will give an exact example for us to see that. I will give an exact example for us to see that. Okay, so the first example. So as you can see, I was just trying to explain on how to deal with partial fraction decomposition for linear factors. So I'll just give an example, then we'll tackle the example, then we'll integrate that example. So I'm given, for example, I'm told find the integral, okay? Find the integral of 5x minus 3 divided by x squared minus 3x minus 4 dx, okay? Something like that. So from there, we'll have to, we said, you factor the denominator, right? So we'll have to factor our denominator. So factoring our denominator, we should say product sum. So our product, okay? Our product equals to, we usually take the coefficient here multiplied by this, right? So our product is minus 4. Then our sum is the same as the coefficient of the b. Okay, it's not the coefficient of b, just b. So it's just minus 3. So what are the two possible numbers? Let me just see. So the two possible numbers. So we'll just try to find the two possible numbers. The two possible numbers here are. So I was looking for the two possible numbers. So the two possible numbers are -4 and 4, such that when you multiply these and these, you get -4. When you add them, you get -3, right? So from there, let's factor out. So we'll write x squared. X squared. We usually start with the negative, but you can just start by with the positive, but I usually prefer starting with the negative, so it will be -4. Placing this x here, then you add 1x, so it's just adding x, then -4. Okay, so place the bracket, and then place the bracket. So from there, factor out x from this part, so you get x into x minus 4. Then you add, from here as you can see, this is just this, so it's just +1 outside into x minus 4. Okay, so taking this and this, joining them together, so we get x plus 1. Then taking one part, so there are two parts for that, but taking one part, so we get x minus 4. So these are the two factors for this, for the denominator for this quadratic function. So from there, I will clear this, and I will write now. I've already found. Okay, I was trying to find the factors for this. So the factors are that. Okay, so from there I'll write the integral of 5x minus 3 divided by, now for now I'll replace with my factors, so I'll replace by x plus 1, okay, multiplied by x minus 4, right? Don't forget to place a dx, So from there, I will decompose this fraction, okay? But now let's assume the integral sign. Let's decompose this fraction. So as decomposing the fraction, we get, how do we decompose? We say, from my example, we say 5 over 12, we can decompose it as a over something plus b over something. For example, 12 and again 12. Maybe the factors for this maybe 5 times 5 plus 6, for example. Okay? So I'll say a over 5 and a b over 6 or something like that. So I'll try to decompose that. So decomposing 5 x minus 3 divided by x plus 1 and again x minus 4, we will get, you take a constant term, for example a, this is just a number outside you want, then you divide it by the first part. There are 2 pairs for this, there are 2 factors. So for example, if you take a, you divide by x plus 1, so divide by x plus 1, okay? Then we'll add partial fraction. We are trying to add 2 different partial fractions to make this whole fraction, right? So again, we'll say b divided by this, divided by x minus 4, okay? So from there, we'll try to find the values of a and b. We'll try to find the values of a and b. So, in finding the values of a and b, we will say multiply this side with the denominator, again multiply this part with the denominator, again multiply this other part with the denominator. So I'll just multiply for you guys to see. Just multiply with the denominator. Multiply by the denominator, I will place my bracket, then I'll multiply by this denominator, this other side. So I'll multiply by x plus 1, x minus 4. Then again this part I'll multiply by x plus 1, x plus minus 4. Okay? Again this part I'll multiply by x plus 1, x minus 4, right? So from there, I'll try to cancel. So these, as you can see, we go that part. I'll be remaining with 5x minus 3 equals 2. So these other parts, these will go with that. I'll remain with a multiplied by that. So I'll remain with a into x minus 4. Okay? I'll write my addition sign. Again here, x minus 4 goes with x minus 4. I'll remain with b multiplied by that. So I'll remain with b into x plus 1. Right? I'm trying to decompose that. So from there, how will you find a and b? There are 2 methods. So number 1, you can expand. You can expand. Okay. Number 2, we can choose the value of x. Okay. The value of x. Okay. This is just same as elimination. Okay. But it's advisable to use the expansion. So we'll try to use the expansion for, you can get a very long expression. So we just have to expand. It won't be suitable for choosing. So I'll just try to explain that with the expansion method. So we'll try to expand. So in as expanding, just the normal expansion. So I'll just write 5x minus 3 equals to multiply a throughout by opening the bracket. So we'll get ax minus 4a, right, plus bx plus b. So this is the expansion. So this is a quite easy method. So from there, how do we find our a and b? We'll have to choose the coefficients. For example, this part has an x, this part has an x. We place it aside. So for example, I'll say my ax plus bx, okay? And say my ax plus bx, and put them aside, then I will factor out my x, so I'll get my a plus b into x. So as you can see, this part is the coefficient of x, right? A plus b is a coefficient of x. So you will compare your answer with these other parts. So as you can see here, there's an x term. So the x resembles the x. So the coefficient is 5. Okay? So I'll say my a plus b is the coefficient of x. So it's just the same as 5. Okay? So we are clear with this and this. So the remaining part is now the constant term. There's no x. So the constant term that remains is minus 4a plus b. So I'll write minus 4a plus b, but there's no x term, so it's just a constant term. As you can see, negative 3 is a constant term. So minus 4a plus b is a constant term, so it will be negative 3. Okay? So from there, I'll find my a. What's my a alone? I'll take my b the other side, so I'll get my a as 5 minus b. So from there, I'll replace my a with this part, so I'll get minus 4 into what's my a? My a is 5 minus b plus b equals to negative of 3. Okay, so I'll just open the bracket and get minus 20 plus 4b plus b equals to negative 3. Okay? So what's my 4b plus this? I'll get my 5b equals to, I'll take 20 to the other side. It will be positive, so it will be plus 20. So it is plus 20 there. It will be 17. Okay? So the value of b will be 17 over 5. Okay? So once you reach here, you will get your value of b. So once you get your value of b, let's find our a. We said our a is 5 minus b, right? And we got, okay, let me go here. Our a is the same as 5 minus b, but what's our b? Our b is 17 over 5. 17 over 5, so from there, just perform your LCM. So our a will be 8 over 5. Okay, so that will be our a. So from there, keeping in mind we had dropped our integral, so I'll just write again my integral. So the first part, the integral was the integral of 5x. And the total integral just for us to find that, so divided by x plus 1. These are our functions that we are given. This is the integral that we are given. So I had splitted it, I had decomposed it to this. Okay? So it's just the same as I'm splitting again the integral twice. Okay, so I'll find the integral of that. So I'll find the integral of a divided by x plus 1 dx. Okay? Then I'll add again the integral of b divided by x minus 4 dx. Right? So this is what we'll be evaluating. So we were given this, yes, but we have decomposed that to this. So this is the integration that we'll be performing. So from there, just replace your values. So just replace what's the value of this. So I'm told, so here I will have to integrate this part. So my value of a, it was 17 over 5 divided by x plus 1. Okay, dx. Then I'll add that to what's my b? My b was 8 over 5 divided to x minus 4 dx. Again, this is the integral. So from there, I will take. So sorry. This is part B. So as you can see, my a. What's my a? My 8 over 5. My a is 8 over 5. So this part, this is my a. My a is 8 over 5. Not 17, but 17 over 5 is just the b part. So my a is 8 over 5. Then my b is 17 over 5. My b is 17 over 5. Okay? So from here, I'll take this constant term outside the integral, so I'll get 8 over 5, the integral of 1 over x plus 1 dx, plus, again here I'll take my 17 over 5 outside, into the integral of 1 over x minus 4 dx. So from here it will be easy. So what's the integral of this? So in finding the integral of this, I'll write 8 over 5. Let me just write, I'll try to explain. Multiplied by the ln of the absolute value of the denominator, x plus 1, okay, plus 17 over 5 multiplied by the ln of the absolute value of the denominator, x minus 4. Then I'll add my constant c. So that's our answer. But why am I allowed to write ln of x absolutely? So I'll try to explain that. Once you're given an integral, from, for example, 1 over u, we usually say its integration, you get ln the absolute value of u, right? So that only applies where once you find your derivative, when you find the derivative of the denominator, so when finding the dy dx of the denominator, for example, let's use this. Okay, so I'll just say over x plus 1. So when I'm going to find I'll find the derivative of the denominator. What's the derivative of this denominator? It's just 1. Okay? So once the derivative of the denominator equals or it's the same as the value in the numerator, we are allowed to write ln of the absolute value of the denominator, right? Plus 1. So that comes here. So when I find the derivative of this denominator, I'll get 1. Okay? So my derivative is 1. Okay? So 1 is the same as 1. So I'm allowed to write ln of x. Again, what's my derivative for this? It's just 1. The derivative is 1. So as you can see, 1 is the same as 1. I'm allowed to write ln of x. So that's an example on linear factors. My second video will be on repeated linear factors. Don't forget to like, share, and subscribe. Thank you.